Yeah, hello and welcome to this short discussion on the status of telco clouds. My name is Stefan Schnitter and I'm a partner at Detecon, leading infrastructure and cloud transformation topics. And Detecon is the management and technology consulting arm of Deutsche Telekom. I also welcome Raul Sauer, who is with me today. Raul is responsible for telco cloud platforms at Deutsche Telekom, and his team is operating cloud infrastructure across Europe for telco workloads. Raul, can you introduce yourself briefly and describe your area of responsibility a bit?
Sure. So my name is Raul Saura. As you said, I am responsible for telco platforms in one part of the Deutsche Telekom organization called TDI. Okay, what we do basically is we offer a collection of products and services from a centralized point, for the use and for the scale across the NatCos. NatCos is, the internal term in Deutsche Telekom we use for the subsidiaries of Deutsche Telekom in the countries. And yeah, that's what we do. We run OpenStack-based platforms, Kubernetes-based platforms, plus security services and a collection of other ecosystem services. And we offer this standardized infra for as of now, mainly for CNF and BNF, so network function execution in the NatCos. That's basically it.
Mm-hmm. Yeah, thanks. So you're doing this for quite some time already. So how would you characterize the status today? So what is the status of your operations and the status of Telco Cloud?
Okay, kind of state of the republic discourse. Look, we started in 2016, so it's been a while already, and I can see how things have evolved. So we are, let's say, in a better position that we were back in the day in order to achieve, the original intent of decoupling the infrastructure from the network functions and also bringing this agile methodology of short cycles of improvement, fixes, and whatnot into the network functions. We are getting closer, and I think that Kubernetes has been very instrumental into that. The differential between the difference between CNFs and BNFs is quite remarkable, and Kubernetes is a little bit the instrument to force it to some degree, because Kubernetes brings some restrictions on how you can architect your application and how the lifecycle management is run. And in the past, OpenStack was way too open. Every vendor had a BNF manager that runs the lifecycle management and things like that, and it was very complicated. So I would say that we are getting there. That dream of having a fully decoupled infrastructure to run network functions and also automated lifecycle management, we are getting there. We are not yet there. There are still a couple of remarkable obstacles that we are now, addressing.
Yeah. I mean, the reason why this journey is quite long and not always straight is also depending to what you run on the cloud for telco workloads. I mean, telco applications are not necessarily the most cloud native if someone comes more from an enterprise perspective. And also the requirements regarding stability, resiliency are a bit different in what you do compared to enterprise clouds. How do you see the situation with applications, telco applications today? Are they able to reuse kind of modern cloud infrastructure concepts? Has this reached a really cloud native level?
Well, I don't think that we are at the cloud native level. There is still a lot of, coupling between the hardware and the application, something that you don't necessarily want in a cloud native environment. But we are moving forward. I mean, now we have applications based on, containerized network functions, so applications that are at the core microservices driven, stateless in most of the cases. For example, I can tell you how it was in the virtual machine world. We had this experience with voice signaling services like IMS, where if you had to restart a compute node in this system, the calls that are going through that compute node are dropped. And then this complicates a lot the operation because you need to wait until all the calls are dropped, and sometimes can be hours, and then it's for one server, and you can imagine how the logistics is complicated. Yeah. With CNF, the vendors already taken a full step forward for the cloudification of this architecture, and now we have stateless workers that pick the sessions from a distributed database, and this enables a more agile approach, so you can really upgrade a system while it is running. It should not die, and the architecture is there. As of now, we still have problems because the application is still fragile. I can explain you, for example, without mentioning the vendor, but we set up this test in our labs where we deploy a full 5G SA, okay, and then do a full performance test on it, like throwing all the traffic the application, the network function can swallow, and at the same time upgrade the infra. So upgrade the Kubernetes layer while it's running, and we were monitoring and recording the whole thing. Was a PR stunt that we wanted to use to tell our networks, like, look, guy, now we can do it. It works. Only it didn't, at the end of the process, it still died for a random reason because the database, blah, blah, blah. So there's still fragility, but I think that somehow now it's time. Now we are not discussing anymore the paradigm. I think that the paradigm is there, but it's just there now. These days it's available. We need a little bit of more refining and being more, let's say, less fragile, and especially in a business like telco, which is so regulated and so afraid of risks and afraid of incidents, which I mean, for good reason, by the way. But we are getting there.
Yeah, and I mean, one of the topics that was always seen as an obstacle is that especially applications that have a high user plane importance or high network throughput. I mean, especially if you're in the cloud, you're stacked a lot of layers on top of each other. How do you see that at the moment? Is this problem of supporting really high throughput applications with a kind of large network bandwidth, low latencies, is something which we master? Or is there still open topics?
But this touches a little bit on the coupling of hardware and the applications. Yeah. There's a strong push still from the vendors, something I think that needs to evolve for the strong coupling. So we still have to discuss with the vendors our server setup, which version of the NIC, which driver, kernel, BIOS parameters. All of that should be decoupled, but we are not yet there. It's not impossible to do. I mean, we can run our CAS platform, our Kubernetes platform on top of OpenStack, and then rely on the abstraction of virtual machines and things like that. But this is not the preferred setup, and sometimes it's not worth the fight. At this point in time, going bare metal for our CAS clusters is the norm. And I think it's okay. Look, for big enough deployments, you don't get a lot of benefits in terms of resource utilization with virtualization or without. It's more about the isolation and the decoupling between the hardware. That is something that is not there, and it's problematic. It's problematic because you have this kind of compatibility matrix nightmare scenario where you cannot change this without affecting that, and all of this gets complicated when you face operations.
Yeah, I mean, if you think at the challenges that you still have today, we did touched some of them. How would you look at the challenges still ahead? So what are the key challenges that you would love to solve in the next like 2-3 years to make it really like a smooth technology, but also operationally? Yeah, so it's not only about technology itself. What would come to your mind?
Yeah, so we are infra, so we are the lowest level of the food chain, I would say. So we are typically, we live on the trenches, and for us it's very important the operational stability and the everything around automation, productivity. These are the parameters more than the new technical feature. That's cool, but what really drives our business is to be efficient and stable. Okay, and for that, let's say the dream scenario would be that you have these systems where you can push a new version of the infra, and the system will pick the version, put it on the automatic test framework, pick one of the CNF, do a full automation test, green light this one, the other, and this pipeline eventually goes to production, and you change the version in the systems. By the way, these days, there is the technical exchange in Bonn, and if you know Abdu, he was actually mentioning that the ambition is to patch systems in one day and do releases every month instead of every year. So it's a lot of ambition. But we are not that far. So we have full lifecycle automation on the infra, it's completely automated. This was reached. On the application side, there's some lifecycle management automation, especially for the onboarding and things like that. But we are missing the glue for everything. I'm wary of using the word orchestrator, but you know the idea. We need this system, and this is what we are working now to have. This is what we are pushing now, all this effort, because we are actually close. So independently, all of the pieces like test automation is automated. The lifecycle management of the application is mostly there, for the infra is there. And if we could put everything together, and then we will have really an agile implementation of a network function. And this is the aim for me. And it's at reach. It's not going to happen next year, but probably in 2 or 3 years, we will reach that state.
Yeah. Okay, now we touched already a lot of your wishes. Let's say what would be like an improvement, especially from users of the cloud, or also from the providers of applications. So you talked about orchestration without calling it orchestration, and this kind of hardware decoupling. Is there anything else that you would really wish from people using your cloud, or the companies providing the software, especially for telco solution providers, that they should do differently?
I mean, apart from the boring stuff on, how make things more automated and more resilient and all of that, on the exciting side, I look towards, these use cases for ORAN, these very extreme edge situations where you need to have a cluster at the antenna side to do the signal processing and all of that requires, more significant leaps in terms of design, like having one single server cluster and integrating hardware acceleration and whatnot. And we are exploring that, and we are quite serious with ORAN. We are also quite serious with bringing also IT workloads in our TCAS product. TCAS is actually the internal name for the managed Kubernetes solution we run. And there's a lot there. There's a lot that still can, we can expand into. And these two things, I think, that are, the direction we are taking these days.
Okay, that's so. I was told that we can't have any discussion without mentioning AI these days. But it's actually maybe not only a joke, because I mean the applications are transforming in this direction. More and more artificial intelligence components get into play. How do you see it from an infrastructure point of view? Do you see a emerging need to evolve CAS products towards GPU support, or supporting infrastructure options for AI workloads? How do you see that?
So, well, this is a very, very abused term. Obviously, AI means many things. We are talking here about large language models. We are talking here about machine learning in other scenario or what. So we are taking some steps. We are not building our own LLM. Just forget, that's not going to happen. But we are now working, for example, in a project called MLOps, where we want to implement machine learning operations. And we are at the very early stages. At some point, we need to face the challenge on building a training cluster, where we will need specialized hardware, some kind of GPUs, to do all the dot product that is involved in machine learning. But I think that we are at the beginning. I mean, we are more users than provider of AI. Of course, when we are coding, we are using Copilot and things like that, and we are using ChatGPT to summarize a lengthy meeting and things like that. But in terms of providing AI services, we just started. I'm a little bit curious. I'm not in all the details with this project, but I'm a little bit curious on where the data is coming from, because at the end of the day, it's all about data. With AI, you don't have good data, you will not have a good network. So probably this is going to happen. As I said, the MLOps is running, and we will see. We'll see.
Cool. Okay. Yeah. Thanks a lot, Raul, for this short but very interesting discussions. Thanks for taking the time. And
thanks for having me here.
Until next time, Raul. Yeah. Bye-bye.
Thank you. Bye-bye.
Okay.